Edge computing is a distributed computing framework that brings enterprise application closer to the data sources such as IoT device or local edge servers. This is proximity to data at its sources can deliver strong businesses benefits. Faster insights, improved response time, and better bandwidth availability. However, this virtual flood of data is also altering businesses, computing practices, limitation on bandwidth issues with latency and unpredictability. A network outage can all work together to hinder such invaders. Bandwidth. This is the amount of data which is a network can carry over time, usually expressed in bits per second. All networks have a limited bandwidth, and the limits are more severe for wireless communication. This means that there is a finite limit to the amount of data or the number of devices that can communicate data across the network. Latency. This is the time needed to send data between 2 points on a network. Although communication ideally takes place at the speed of light, large physical distance coupled with network congestions or outage can delay data movement across the network. Data is the lifeblood of modern businesses because it supports real-time control over crucial businesses, processes, and operations, and provides valuable businesses insight. The present organizations are flooded with an expanse of information, and enormous measures of information can be regularly gathered from sensors and IoT gadgets working continuously from distant area and in unwelcoming working condition in place on the planet. However, this virtual flood of data is also altering business computing practices when it comes to moving ever-increasing rivers of real-world data. The conventional computing paradigm, which is based on a centralized data center and the internet as we know it, is not very suitable. Using edge computing architecture, businesses are addressing these data issues. Edge computing moves some storage and computing resources closer to data source than they do at the main data center. Instead of sending raw data to a central data center for processing and analysis, the work is done where the data is actually generated. Whether in a retail store, a factory floor, a bus utility, or throughout a smart city. Only the result of the computing works at the edge are sent back to the main data center for review and other human interactions, such as real-time businesses, insights, equipment, maintenance predictions, or other actionable answers. Accordingly, edge processing is reshaping IT and business registering. Take a comprehensive look at what edge computing is, how it works, how the cloud affects its edge use cases, trades-off, and things to think about when implementing it. With brands undergoing a digital transformation, businesses are well poised to take advantage of next generation's networks propelled by the power combination of 5G and multi-access computing. Throughout its increased performance, 5G can enhance edge computing applications by reducing latency, bettering application response times, and improving the ability of enterprises to collect and process data. 5G and edge computing are two inextricably linked technologies. They are both poised to significantly improve the performance of applications and enable huge amounts of data to be processed in real time. 5G increased speed by up to 10 times that of 4G, whereas multi-access edge computing reduced latency by bringing compute capabilities into the network closer to the end users. The data is processed and stored at the network's edge, not at some distant data center. Multi-access edge compute (MEC) provides both an IT service environment, the cloud's computing capabilities to enable real-time enterprises. By 2025, 75% of enterprise data will be proceeds at the edge, thanks to the increasing adoption of 5G technology. 5G technology, an era of user-centric network by bringing in the concept of networks, slicing, and composable networking. This has caused a fundamental shift from network-aware application design to application-centric network provisioning. Virtualization from the core of the edge. apart from the core of any network, the radio access network or RAN edge can also be virtualized, making edge on demand possible. Edge computing is a term that describes the duties of device at the edge of the network. Every network has a core and an edge, a trunk and a branches. The core trunk is where the network starts, and the edge branch is where it ends. The edge is the point at which external users interact with the network. These users may be actual people or other external devices, known as peripherals. Virtualization is an essential component of edge computing, allowing admins to quickly and easily manage workloads, shifting between servers. Virtualization plays a critical role in many edge scenarios, including gateways or micro data centers that process data produced by sensors at the edge, or apps running in containers that are hosted on virtual machines. Edge virtualization is the practice of using software versions of physical computing resources at the edge of a network, closer to the device that produces data. Instances that can then be copied and distributed to many different types of hardware. Extensive reach. MEC is all about extensive reach, and there is a huge potential for Tier 2, Tier 3, and Tier 4 cities in India to benefit from this network. Performance and reliability. MEC is built right to support even the most demanding of applications and use cases. Edge computing can help improve system reliability by distributing the processing load and reducing dependencies on the cloud. For example, if an edge device goes offline, it can continue to operate independently. However, if a cloud-based system goes offline, all connected devices will be affected. Edge computing. Edge computing will emerge as the most important approach to resolving this problem in light of the upcoming 5G network technology. Traditionally, centralized cloud computing is having trouble meeting the quality of service or QoS requirements for many applications because of the rapid increase in the number of mobile devices. Where the cloud has massive compute, storage, and networking resources that are tightly geographically associated, usually in one or two very large data centers. Edge virtualization has a very large number of locations, each with a modest complement of resources. Because 5G networks need to be highly distributed, each network node or edge device need to have local virtualized resources. A 5G network will be impossible to implement if each node needed to access resources from a centralized location for updates or maintenance because of the sheer number of edge nodes and their complex reliance on each other to function. Edge computing implementation. Some research efforts have already focused on designing edge computing models In order to put the aforementioned architecture of edge computing in action, the two models listed below typically dominate a software-defined model and hierarchical model, respectively. Hierarchical model, the edge architecture is divided into a hierarchy that defines function based on distance and resources, because edge or cloud servers can be deployed at various distance from end users. Consequently, a hierarchical model is appropriate for describing the edge of computing network structure. The hierarchical model has been the subject of numerous studies, for instance, hierarchical et al. A hierarchical model that incorporates cloudlet structures and mobile edge computing or MEC server were proposed in mobile. Mobile user can get the service they want in this model because MEC can meet their computing and storage needs. The regional edge cloud is created as a three hierarchy of deployment. Edge servers in this model and the cloudlet servers are placed at the network's edge.
Good day everyone, I am Wency Permentila and I am the second reporter in our group, and I will discuss the second edge computing model. The second edge computing model is the software-defined model. The managing of edge computing for the Internet of Things will be extremely difficult due to the hundreds of applications and millions of end users and devices. To deal with the complexity of managing edge computing, software-defined networking or SDN may be an option. There have been various explorations on SDN model. Examples include Jarawe. In order to combine the MEC system capabilities with those of software-defined system, a software-defined model was proposed. The cost of management and administration can be reduced in this manner. An application-specific MEC model was proposed by Du and Nakao. A mobile virtual network operators or MVNOs network is taken into consideration in their model under the software-defined data plane paradigm. The authors created mechanisms for mobile-friendly optimization and hop-count tethering detection. Fairness among users can achieve by controlling the number of TCP concurrent connections through the designed mechanisms. An edge operating system that makes us freely available open source software to create powerful network and service platform was proposed by Manzalini and Crespi. Salman and MEC, Software-Defined Network or SDN, and Network Function Virtualization or NFV were three brand new ideas were proposed to combined. This solution has the potential to improve MEC employment in mobile networks and can be expanded further to enable IoT-wide development. Software-Defined Infrastructure or SDI, Smart Edge Architecture called Smart Applications or Virtual Infrastructure has been proposed, and it can be used to help build a variety of distribution, network services, and applications. And what is multi-access edge computing? Multi-access edge computing or MEC is a relatively new technology that offers cloud computing capabilities at the network's edge. This technology works by moving some computing capabilities out of the cloud and closer to the end devices. Hence, data doesn't travel as far, resulting in fast processing speeds. Ideally, there are two types of MEC dedicated MEC and distributed MEC. The dedicated MEC is typically deployed at the customer's site on a mobile private network designed only for one business. While on the other hand, distributed MEC is deployed on a public network, either 4G or 5G, and connects shared assets and resources. With both dedicated and distributed MEC, applications run locally, and data is processed in real or near real time. This helps avoid latency issues for faster response rates and decision making. MEC technology has seen wider adoption in video analytics, augmented reality, location services, data caching, local content distribution, and etc. How does 5G work with multi-access edge computing? Over the years, the Internet of Things and IoT devices have grown tremendously, effectively boosting productivity and accelerating network agility. This technology has also elevated an adoption of edge computing while ushering in a set of advanced edge devices. By adopting edge computing, computational needs are efficiently met since computing resources are distributed along the communication path via a decentralized computing infrastructure. One of the benefits of edge computing is improved performance as analytics capabilities are brought closer to the machine. An edge data center also reduced operational costs thanks to the reduced bandwidth requirement and low latency. Why MEC adoption is on the rise? 5G MEC adoption is growing exponentially, and there are several reasons why this is the case. One reason is that this technology aligns with the distributed and scalable nature of the cloud, making it a key driver and technical transformation. Similarly, MEC technology is critical business transformation change agent that offers the opportunity to improve service delivery and even support new market verticals. Among the top use cases driving the high level of 5G MEC implementation includes video content delivery, the emergence of smart cities, smart utilities, and connected cars. This also showcases the significant role of MEC plays in different IoT domains. Here's a quick overview of primary use cases. There are 4 cases, and it is the autonomous vehicles, smart homes, AR or VR, and smart energy. First is the autonomous vehicle. 5G MEC can help enhance operational functions such as continuous sensing and real-time traffic monitoring. This reduces latency issues and increases bandwidth. The second is the smart homes. MEC technology can process data locally, boosting privacy and security. It also reduces communication latency and allows for fast mobility and relocation. AR/VR. The third one is AR/VR. Moving computational capabilities and process to edge amplifies the immersive experience to users, plus it extends the battery life of AR/VR system or device. The fourth and last one is the smart energy. MEC resolves the traffic congestion issues and delays due to the huge data generation and intermittent connectivity. It also reduces cyber attacks by enforcing security mechanisms closer to the edge. Why you should getting started with 5G MEC? One of the key benefits of adopting 5G MEC is openness, particularly API or openness and the open option to integrated third-party apps. Standards, compliance, and application agility are the other value propositions of multi-access edge computing. Therefore, enterprises looking to benefit for a flexibility and open cloud should base their integration on the key competencies and they want to achieve. One of the challenges common during the integration process is hardware platforms. Limitations as far as scale and openness are concerned. Similarly, deploying 5G MEC technology is costly, especially for small-scale businesses with limited financial backing. Other implementation issues include ecosystem and standard immaturity, software limitation, culture, and technical skill set challenges. To successfully deploy multi-access edge computing, you need an effective 5G MEC implementation strategy that's true and tested. You should also consider partnering with an expert IT or edge computing company for professional guidance. That's all, and thank you.
Good day everyone. I am Gabriel Batan Villapando and I am the third reporter for 5G MEC technology, and this is the key takeaways. Edge-driven transformation is a game changer in the modern business world, and 5G multi-access edge computing technology is undoubtedly leading the cause. Enterprises that embrace this technology in their business models benefit from streamlined operations, reduced cost, and enhanced customer experience. Even then, MEC integration isn't without its challenges. Companies looking to deploy multi-access edge computing technology should have a solid implementation strategy that aligns with their entire digital transformation agenda to avoid silos. Benefits or advantages of edge computing. Number 1. Response time and latency. Every millisecond counts for a company's success. That could end up spending thousands of dollars on downtime or latency. Edge computing can speed up networks by lowering latency. Additionally, the distance that data must travel is significantly reduced when processed closer to the information source. A latency that is measured in microseconds rather than milliseconds is the result. The overall speed, quality, and responsiveness of the service have all improved as a result. Second, high security and less risk. The cloud-based data is highly vulnerable to hacking because edge computing only sends the relevant data to the cloud. This can be avoided. Additionally, a network connection is not always required for edge computing. Subsequently, regardless of whether programmers get to the cloud, not all clients' data is in danger. However, edge computing is not risk-free as a result of this. However, compared to the cloud, this offers a risk profile that may be lower. Number 3. Lesser transmission cost. Because of the reduced bandwidth, edge computing has the potential to significantly cut costs as well as simplify cloud security strategies. Most data does not need to be stored in the data centers because so much of it is now processed and stored locally on servers and devices. At the data center level, edge computing requires less bandwidth as a result. By storing less data in the cloud and processing more locally, data centers can save bandwidth capacity and avoid costly enhancement to cloud storage features that are already in place. Number 4. Scalability and versatility. In a cloud computing system, data must be transferred to a centralized data center. Sometimes, it can be expensive to change or expand this data center. On the other hand, your own IoT network can be scaled at the edge without having to worry about storage. In addition, IoT devices can be installed in this location with just one implantation. And next is the benefits or advantages of 5G MEC. These are the following benefits or advantages of 5G MEC. Number 1, it offers new network services to the customers. Hence, it enables service providers to increase revenue by exploiting the multiple use cases. The second one, applications run in local environment which improves performance and user experience due to lower latencies. Number 3, without changing existing 5G network architecture, service provider can roll out new service for end customers. And second, services and available to customers based on their locations due to OTT. OTT stands for over the top, and the second, it offers security for IoT, Internet of Things service. It offers distributed infrastructure and improves applications reliability and network services. Second, it provides environmental for local policy management for enterprise customers. And it also offers real-time access of data locally under IoT environment. And it reduces operational costs by avoiding requirements of expensive data centers. And it reduces the need of cloud data storage and consecutively saves transport costs. And it also conserves network bandwidth and reduces network congestion. And the disadvantages of edge computing. Number 1, security. Edge computing raises security concerns at each localize of the edge network, despite the fact that it improves security by reducing the amount of data that must be protected in data centers. Additionally, not every edge device has the same built-in authentication and security capabilities, making some data more susceptible to breaches. And second one, infrastructure cost. Network technology always required a significant investment, regardless of whether you choose to put your money into large multinational clouds or scattered edge device for your birthday computing requirements. The strategy comes with its own set of costs for launching and managing edge devices. Despite the fact that investing in a more robust edge network saves money on bandwidth for data centers. For optimal performance and local storage requirements, edge device may require additional hardware and software, and costs can quickly rise when distributed across multiple local geographies. The third one, data loss. Sifting through all of the data in a cloud data center can be time-consuming, but central storage ensures that it will be available when you need it. Critical data could be misinterpreted and accidentally destroyed by an edge device, despite the fact that edge computing processes save space and money on storage. And that's all. And that is our documentation for the 5G multi-access edge computing, MEC.